So in this unit, we reviewed trigonometry. And remember, we use trigonometry to find missing angles and missing sides in right triangles. But what happens when we're dealing with triangles that aren't right angles, or don't have a right angle in it? Okay. So for example, something like,
what unit is this? Oh,
something like this. That's not a right angle triangle. We can't use sine, cos, or tan because it's not a right triangle. However, there are a couple of formulas based on trigonometry that we can use to find missing sides or angles in non-right triangles. Okay? And it depends, the formula that you use depends on the information you're given and what you're trying to find. Sometimes we use a formula called sine law. Other times we have to use a different formula called cosine law. Okay? So the sine law. And again, this is used a lot, architecture, engineering, construction. Okay? All of this is used. Again, this is review for you because you've all taken pre-calculus in previous years. You've taken grade 11 pre-calc. So to find that the sine law formula is one side over the sine of its opposite angle in a non-right triangle will equal another side over the sine of its angle opposite, which will also equal the third side over the sine of its angle opposite. You do not have to worry about writing this on a reference sheet because you will always be given this. Okay? This will be on the formula sheet. We could flip all these around and it's the same type of formula, but it's like I said, it's the same thing, so I'm not going to write it. So let's see how we can use this, because what we want to do is we're going to set up two of these which equal each other, and then we're going to know three pieces of information, and we're going to solve for the missing piece. So let's just look at an example. Okay. Where we use sine law. So here we have a non-right triangle. And we are asked to find the length of side A. Well, what angle is opposite side A? 60. I know this side. What angle is opposite this? 70. So therefore, using the sine law formula, I can say this side, which I don't know, A, over the sine of its angle opposite, so the sine of 60 degrees, will equal the side I do know, 80, over the sine of its angle opposite, which is 70 degrees. So it will equal 80 over sine 70. That's how you set up the formula. Now remember, this is equation solving. We want to get A by itself. Okay? Well, when you've got a single fraction on either side of the equation, there is a quick way you can get rid of the fractions. And that's by cross multiplying. This times this
will equal this times this.
So that's a way that we can get rid of
The fractions. So A times the sine of 70 degrees will be the same value as the other multiplication, A times the sine of 60 degrees.
Well, I haven't got A by itself yet. There's a times sine 70. So what do I got to do to get A by itself?
Divide by sine of 70. So those cancel.
So to find A, this is what I'm going to do on my calculator. What? I don't. Can you follow along on Teams?
Yeah.
Okay. Making sure that I'm in the right mode, degree mode. So we would do 80 times the sine of 60, get that answer, and then divided by the sine of 70.
And it doesn't say what to round to, so I'll go one decimal place.
If you do calculations correctly, you should get 73.7. So with sine law, you want to set up a single fraction on either side, cross multiply to get rid of the fractions, do some more algebra to get the unknown by itself, and then use your calculator to find your answer. Okay?
When do we use sine law? Right here. Whoops. That didn't work. Try that again. Why is it not letting me go to highlight? Okay, we'll just underline it.
As long as you know both an angle and its opposite side, that's when you use sine law. If you know an angle and its opposite side. If you don't, sine law is not going to work. That's when we use cosine law, which we'll talk about on Thursday. Okay? Okay, let's do some more practice. So this one, it's a non-right triangle, so we can't use the right triangle trig. And we have to find all the two missing sides here and the missing angle. So we've got to do a lot of work on this one. Okay?
Let's deal with the missing angle first. Angle B.
Can you find it without using trig? How would you do it?
180 minus the other.
Yeah. Because I know two of the angles, add those two angles together.
And subtract it from 180, or 180 minus 80 minus 40. Now for the sides, we're going to have to use sine law.
Okay, so this side that I'm trying to find A over the sine of its angle opposite. What angle measure is opposite A? 80 degrees. Now I've got to use the side that I know, 17.4 over the sine of its angle opposite. Well, what angle is opposite 17.4? 40.
That's the equation you'd have to set up to find A.
Cross multiply. To get rid of the fractions. So A times the sine of 40 will equal 17.4 times the sine of 180, or sorry, sine of 80. To get A by itself, I have to divide both sides by sine 40.
So then on your calculator, that's what you would do. 17.4 times the sine of 80. Get that answer divided by the sine of 40, and you should get 26.7.
So we found A. So the only thing left we have to find is B.
And I can use sine law again. Can somebody tell me what it would look like?
B over sine 60. And then use the same fraction from the previous, 17.4 over sine 40.
Yeah, it's the same one you can use.
You could have used 26.7 over sine 80. That's absolutely correct.
Cross multiply to clear out the fractions. And it's pretty much going to look the same way as the previous one we just did. Slightly different numbers. Divide by sine 40. Divide by sine 40. And then when you pull out your calculator and punch it all in, assuming you guys know how to do that,
You'll get 23.4. Okay. So like I said, we use sine law when you know a side and the angle opposite. So for this example, we're not going to actually find anything. You're just going to tell me whether you can use sine law. As long as you know a side and its angle opposite, you can use sine law to find the other stuff. How about the first one? Yeah.
because I know this. So yes.
No.
No, because it's a right triangle. So we would use right triangle trick. Technically, sine law would work with right triangles, but let's stay away from it. How about C?
No, I can't, like,
No.
and I don't know these, I have no idea what these angles are. And these are the opposite sides, so no, there's no way I can figure it out.
How about this one?
Yes, because you could find this. It's 80 degrees because I know the two other angles. Therefore, I know a side and its opposite angle. Therefore, I can use sine law. So yes.
Okay.
Wait, Isn't that 90 degrees?
40 plus 60 is 100. And then 180 minus 100. That's okay.
I just like that, like, because, like, look at this.
Yeah, yeah, I know, sometimes it does. Okay, good. So we've seen how we can use sine law to find the missing side. How about missing angles? Well, you still set it up the same way. So let's find angle A first. What side is opposite angle A? 7. So therefore, I could write 7 over the sine of A equals. Well, what's the side and angle that I do, opposite angle that I do know?
8
8 over sine 58, right? And again, just like we did finding the missing side, cross multiply to clear the fractions. So I get 8 times the sine of A equals 7 times the sine of 58 degrees. I need to get capital A by itself, so the first thing I need to do is get rid of that times 8. I'm almost there. How do I find the missing angle? How do I get rid of just sine?
inverse?
Inverse. Sine inverse cancels out sine, which means you got to do the sine inverse of this side. So you got to do sine inverse 7 times sine 58 divided by 8. And when you do that, you should get about 47.9 degrees. Make sure you know how to do that on your calculator. Make sure you know how to get that answer. So I know that this is 47.9. How could I find angle C? Yeah, I mean, I could do this again, but because I know 2 of the angles, can't I just add these up and take it away from 180? So angle C, I just do 180 minus the sum of these 2 angles, 47.9 and 58. And when I do that, oh, I don't have the answer. Didn't finish that question in my notes. What do we got? What? 74.1, isn't it? 74. Okay. So those are what we would call straightforward questions to find missing sides and angles using sine law. But usually what you should be expected to do is a bit more of a problem. Okay, an actual problem. So let's look at a couple of actual problems to finish this out. So this one.
So you're on a plane and you're flying this way and you're heading into a thunderstorm. So you are diverted off 21 degrees of your path. You fly for a certain distance and then you change your course to go back to your original path. We need to know how long the detour was. So what am I trying to find here? How much further did we have to go? Well, we have to find x plus y. Oh, that was 7. We have to find x plus y. And then you have to add them together. Okay. Well, remember, we've got a non-right triangle here. I know 2 of the angles here, so I got to find each of these separately. So I can go x over sine 21 equals 70 over sine what? Can I find this angle?
Yeah.
Yes. Add these two together, subtract it from 180. So I get 56. What should I get? 134? No.
183.
124.
Yeah.
124.
180.
Or just do 180 minus this minus this. That's all. Same answer.
No, the problem is I was putting in the wrong number.
Oh, I see. I got you.
Not the math.
And then for y, might as well do y. It would be y over sine the angle its opposite, 35 degrees, equals the same fraction that I wrote when I was finding x.
So I've got to solve both of these.
So cross multiply to clear out the fractions. X times sine 124 is equal to 70 times the sine of 21. Divide both sides by sine 124.
Do that on my calculator and I will get approximately
30.3 kilometers.
and then I find y the same way.
Cross multiply to clear the fractions. Y times sine 124 is equal to 70 times sine 35. Divide both sides by sine 124. And for this one, we get 48.4 kilometers.
So the total diversion,
Well, he flew 48.4 and then he flew 30.3.
and we want to find how much farther that is than 70 kilometers.
So we've got to add these two and subtract 70. 8.7 kilometers farther. Yeah, that's how much further the detour was 8.7 kilometers. Okay. And we'll look at one last example. That's more of a word problem. This one here. So we've got two observers on boats. So these are the different boats. One of them is on boat A, or observer A is on this boat. Observer B is on that boat. Okay, and they have located a sunken ship using sonar, which is down at the bottom of the water that they're on, somewhere in between them. Okay. We know that the angle of depression from observer A, so the angle of depression, that means the angle with the water and the line of sight going down to the ship. That's the angle of depression. Because it's always formed between a horizontal line and whatever you're looking down, because depression means down. From observer B, his angle of depression, so the angle from the water line with the line looking down at the sunken ship is 36 degrees. We're also told that the two boats, or the two observers, are 450 meters apart. And using all that information, I need to find this. How far below the surface is the sunken ship? So this, and I'll just call it X, that's my ultimate goal, is to find that. Hmm. We do this.
And then
Okay.
you can use like
Yeah.
sine multiplying on this height, and then you can use it's just this keeps and then you would probably have to use like cosine because you have a right angle triangle.
Well done.
Yeah.
Yes, well done. Very well done.
So let's find this angle by doing 180 minus 40 plus 36. And that gives us 76. 180 minus 76 gives us
104 degrees.
So now focus on the big triangle. So this one. So this is A, this is B, this is S. We just found this, or sorry, this is 40, this is 36. We just found this to be 104. And we know that this is 450 meters. So yeah, let's find one of the missing sides.
Doesn't matter which one.
Let's do B.
So this one?
Yeah, because it'll be a small.
Okay.
So let's find B.
Well, let's set up sine law. So the missing side B over the sine of its angle opposite, which is 36 degrees, will equal what?
1/3, 450 over sine of
Excellent. Well, multiply to get rid of the fractions. So we go B times sine 104 is equal to 450 times sine 36. Divide both sides by 104 to get B by itself. Sine 104 to get B by itself.
And B works out to approximately 272.6.
So we know that this is now 272.6. So let's use this right triangle to find x.
So now we're going back to regular trig.
So now I'm looking at this, CA, we call this x. We know that this is 40 degrees. We just found that this was 272.6 meters. It's a right angle.
What's the trig? What trig ratio?
Well, if we know this angle, what's the name of this side?
Opposite, adjacent, or hypotenuse?
Opposite. What's the name of this side?
Hypotenuse. So opposite, hypotenuse
Means sine. So the sine of 40 degrees is equal to x over 272.6. Multiply both sides by 272.6 to get x by itself. So 272.6 times the sine of 40 is going to equal x.
Pull out your calculator and do that, and you would get approximately 175 meters below the water surface. Okay? Yeah. I mean, technically, I should be using that. You're right. I should be approximating. But that you wouldn't get a communication for that. You'd be okay. Yeah, if you put either one, you'll be okay. So these last two examples, they're kind of more of what you may see as an example on the provincial. And usually on the provincial, every year, they have a question that uses sine law and they have a question that uses cosine law.
So if you don't have to do those are marks you can get. Okay?